Welcome back to our database design and development unit. In today's lesson, we will finish off the design topic by looking at data dictionaries. Our learning intentions are as follows. We'll learn how data dictionaries are used to model entities and their attributes, and we'll learn how sample data is used to inform the contents of a data dictionary. As always, we have some success criteria, and for today's lesson it is as follows. We'll be able to analyse sample data from 3 or more entities to populate a data dictionary, be able to describe 5 data types and assign them to the appropriate attributes. We'll be able to describe what is meant by an attribute size and assign appropriate sizes to the attributes themselves. And we'll be able to describe 4 validations and apply them to the appropriate attributes. In our previous design lessons, we've looked at entity occurrence diagrams and entity relationship diagrams, which focus largely on the structure of the database. Although we will discuss some structural elements, the focus of today's lesson is to do with the attributes which will be included within the data dictionaries. A data dictionary will produce a clear plan of how those entities and the identified attributes will be implemented. The dictionary will include things like the entity name, the names of the attributes within that entity, the data types of those attributes. We'll identify the key fields. We'll also look at the data sizes of each attribute and if any validations are required. We learned about the data types of attributes in National 5. Let's remind ourselves about some of these. We have text, which can store a combination of any text and numbers and alphanumeric data. We have numbers, which we can store numerical data. We can store different types of numbers and we can change the format of those numbers. So for example, something like currency would be a subset of a number. We have dates, obviously, to store the format of data, and that format can change in a variety of different ways. We have time, and we have boolean, which is a true or false, yes, no, two-state attribute. We also looked at validations in National 5. We looked at a presence check. This ensures that a field of information cannot be left blank. It means the user must enter a value in there. We also have a length check, which restricts the number of characters that may be entered within an attribute. So we can set that to an exact number. We have a range check, which ensures data entered must be within a certain range. So for example, between 0 and 100. That range check will have a lower bound and an upper bound. Lower bound being 0, upper bound being 100. And finally, we have a restricted choice. And this is used to provide the user with limited options. Those options will be valid options and they can be selected from a drop-down menu. Now let's look at an example from a computer hardware shop. We can see some sample data that we have been provided here. We have 4 entities. Those entities are customer, item, order line and order. We will analyse this data, identify the data types and validations, and we will start to populate a data dictionary using this sample data. We will take our first entity called customer, and the first thing we'll do is we'll identify the primary key. Now, customer ID is very likely the primary key. In this case, it is the primary key. The customer ID is not kind of natural data that we would see exist outside of the database. It's firmly a unique identifier. It also has no repeating data in the sample, so each customer ID is unique, and it will uniquely identify each instance of the customer entity or each record within the customer table. First names wouldn't be suitable as multiple customers could have the same first name. Same goes for surname. It's possible for multiple customers to have the same address. They may stay at the same house, and as such, postcode would fall into that same category. A customer could possibly share an email address, even though emails are unique, though they can be shared. And customer telephone numbers could also be shared. So therefore, we think our customer ID is the perfect primary key. The first entity we will look at is the customer entity. We can see the sample data at the bottom of our image and our data dictionary at the top. We can see that we have our entity name entered into our data dictionary, along with the 7 attributes that we have within this entity. We've also identified the key field, which is the customer ID, as the primary key. That customer ID is a text field. Its data size is 4. We know this because when we look at the sample data, we have consistently 4 characters. And its validation is a presence check. It means that this entity must have a customer ID to uniquely identify each entity occurrence within that entity. Again, first name text, its data size is 20. This would be a reasonable size. Very few people will have a first name with greater than 20 characters. It's important to judge this. We would always look at the sample data and look for the largest entry. We must consider that there might be names that are a little larger, therefore we must give an appropriate amount of characters. The opposite of that is also important. If we give too many characters, this would make our database inefficient and it would use extra backing storage in order to store each first name. That first name will have a presence check, surname, text field again, data size 20, also a presence check, address, it would be a text field, data size 50, having a presence check. Our postcode again would be text, data size 8, again having a presence check. Email, text field, data size 40 and a presence check, and the phone number, which would also be text, data size 11, and we would have a length check of 11 on that attribute. Important to note that the phone number would be text because it starts with a 0. If we were to set this attribute up as a number, it would discard that first 0, and obviously, as we know, that first 0 is very important when it comes to telephone numbers. It's really important to realise as well, we must take this in context. We have a presence check on the majority of the attributes there. If it is vital that we have that information, then a presence check would be appropriate. If we won't use that information, for any great detail or any great purpose, then perhaps we wouldn't require it. Moving forward, we would then look at the item entity. It's important to note that the hardware store only stocks GPUs, CPUs, RAM and motherboards. The store will never stock any products that cost zero or that are free, or they won't stock anything that will cost more than £3,000. Again, we do the same process. We look at that sample data. We have populated our data dictionary with the name of the entity. We have populated the 4 entity attribute names, and we've identified that key field. That attribute item ID, which is the primary key, is a text field. Its size is 7. And we have a presence check there. Looking at the sample data, we can see that one of the item IDs is 7 characters, where the rest are 6. So we'd always go with the largest one. Description, text field, 50 in data size. We have a presence check, and our category would be text. And again we'll go with 11 because motherboard is there. We'd always take the largest one. We would have a presence check there, but we'd also have a restricted choice, and we did say in the note here that the hardware store would only store GPUs, CPUs, RAM and motherboards. So we have 4 options there, and when we're given those specific options, we can put that restricted choice in place. Restricted choice is a validation that is really useful for programmers to implement for their users. There are some advantages to that, being that when inputting data, we can ensure that we have a consistent format of the data being entered by the user, and we will always get a valid input by using a restricted choice. Finally, we move on to price, and that is number, and remember that currency is a subset of the number data type. And we are going to ensure that we have a range here, presence check and a range check that is greater than 0 and less than 3,000. Our third entity, the order entity, again we have done the same things. We have populated that entity name, we have populated our attribute names, our key fields. In this case, we have a primary key of order number and a foreign key of customer ID. We have text for our order number, and its size is 6, and we'd have a presence check. The customer ID being a foreign key is text, and we've got a presence check there, but interestingly we've got something called a lookup from the customer table, and we can do that when we have established a relationship between 2 entities. We can look the data up from the other entity, and because it is that foreign key coming from the other entity, so it's something else that we can do within that, and we'll look at that in some of the practical videos later. We have an order date, which is obviously a date data type, and a presence check. Again, we can format those dates in a variety of different ways practically within our software. And we have the order dispatched, which is a Boolean data type. It's a yes, no, it's a 2-state Boolean. And we have a presence check there also. We now move on to our last entity. We have a note here saying customers cannot have an order line with 0 products on it, and customers cannot order any more than 10 of any individual product. We can see that this entity called order line has one single attribute called quantity. Now you will be aware, and you will see that our data dictionary has 3 attributes populated there. That is because two of those attributes are coming into this entity as foreign keys to link the relationships with two other entities. Those are order number and item ID. We can see within the key field that they are put down as a primary key and a foreign key. Their text type is text, and we will look for a presence check, and the order number will be a lookup from the order entity, and the item ID will be a lookup from the item entity. Those two attributes, as well as being foreign keys, will also act as a primary key for this order line entity. That means we have a compound key here. The combination of both of these attributes together will form that primary key. Let's now look at our single attribute, which is quantity. Its data type is number, and we will have a presence check there. But as per our note, we will also have a range check, which will be implemented to say that the quantity must be greater than 0 and less than 10. We can now bring our entities together in a full entity relationship diagram. We can see we have our four entities, the associated attributes, our identified key fields, the data types, the sizes of the attributes, and any validations that are required. So we have our customer entity, our item entity, our order entity, and our order line entity. We can clearly see that our customer entity has the primary key of customer ID, and we can see this repeated in our order entity as the foreign key, highlighting a clear relationship. This is our one-to-many relationship between customer and order. We can see that order has a primary key of order number, and that attribute order number is repeating in the order line entity as our foreign key in this case. Again, giving us a one-to-many relationship. And item ID is the primary key in the item entity, and again we can see that repeated in the order line entity as a foreign key, giving us that one-to-many relationship. We can also see at this point that our order line entity is an intersection entity or table that breaks that many-to-many relationship between orders and items. We can see that the key fields, order number and item ID, both being foreign keys from corresponding entities, combine to make a primary key for the order line entity, or a compound key. Finally, if we reflect back on our entity occurrence diagrams, our entity relationship diagrams, and our data dictionaries in the design topic, we can see how we can establish the structure and relationships contained within our database. We can also see how we can set up the attributes with their properties within the database to give us a structure that can be populated with data and information. Again, we finally highlight our relationships between our entities here, detailing the cardinality and the relationship descriptions. Thanks for listening, I hope you found this lesson useful, and please like and subscribe for more content.